This is the next video in a chapter on chemical bonding and molecular geometry. We just finished talking about ionic bonding and covalent bonding, how they're similar and different, and now we need some nomenclature to help us give names to those different types of compounds that we're talking about. So this is specifically inorganic nomenclature. We're not going to talk about carbon-based nomenclature that you'll see later in organic, just inorganic. So now that we have moved up in the world from our land of single atoms, we've spent the last few weeks in, to the land of multiple atoms, multi-atom compounds. We need names for these things. We need to learn how to name compounds we are using. And there are lots of different kinds of compounds, and there's lots and lots of different naming rules, but we are just going to focus on the naming rules that are relevant to the types of compounds we are going to be looking at for the next couple of weeks. But there are a couple of questions that you need to ask yourself when you're trying to decide how to name something. This is going to be the unofficial list of questions to ask yourself when trying to name something. Because I would encourage you to try and remember the process rather than to try and remember every specific rule, because this is going to feel a little bit like memorizing, but it doesn't have to feel completely like memorizing. So the first question we're going to ask ourselves is about the bonding type, the major bonding type in the formula. So is the major bonding type ionic or molecular? We talked about how to determine this in the last couple of videos, looking at the properties of the compound, if you know it, looking at how metallic or how non-metallic a particular element is, and how different the electronegativity of the elements are. And then if the compound is ionic, there's a couple of extra things to look for. If it's ionic, we want to look for polyatomic ions. Because those are going to be named slightly different than normal single atom ions. And the other question for ionic compounds is about the metal. Because remember, in an ionic compound, one of the ions is always a metal, and one of them is always a non-metal. So we're going to ask ourselves, is the metal element's charge fixed or flexible? And this is because, remember, we wrote a series of rules for how to determine the charge of a metal element. Those are for fixed elements in groups 1 and 2 and 13 through 18. In the main group metals, they have one charge that they usually take. But for metals in the transition metal block, those charges are flexible and they have multiple options that they could be. So we need to figure out what the charge is before we can write the name. Okay, so the general rule, we're going to write the cation in red and the anion in blue. The general rule for writing an ionic compound is you write the cation name first. You put a space. You write the anion name second. And you stick a suffix onto the end of the name of the anion, "ide." And just so you know, this line is supposed to represent a space. I like to draw the line in. You don't have to draw the line, but if you're not going to draw the line, make sure it's clear whether there's a space or whether there isn't a space, so that it's easy to tell how your spelling works. So Let's look at examples if all the ions are monatomic. So if each of the ions is just a single atom, we're going to use this simple rule for nomenclature. So let's look at something that we should already know the name of without even thinking about it, NaCl. So we're going to follow our question process to help us write the name for this. So the first question is the bonding type ionic or molecular? And remember, we could tell whether something was molecular based on the electronegativity difference. So I think the electronegativity difference here is going to be large. Sodium is a metal. All the way on the left side of the table, chlorine is a non-metal. All the way on the right side of the table, that electronegativity difference is going to be large. So this is going to be an ionic bonding site sort of compound. So we're going to follow the ionic bonding rules that we just talked about. So then I like to go through and make sure I know the name of each of the pieces. So the cation is called sodium, and the anion is called chlorine. Just writing their names so I know what they are before I start adding prefixes and suffixes and such to them. And then when I'm ready, I go ahead and write the name. So the cation's name is written as it is, without any changes. Then we put a space. Then we write the anion. And instead of writing chlorine, we change the ending to be "ide." So we write chloride. That's the only interesting part about that name. Let's do another one. Let's do something you probably don't know the name of just by looking. Al4C3. So again, we're going to try and figure out what the bonding type is first. So we know that aluminum is a metal, and we know that carbon is a non-metal. So that means their electronegativity difference is going to be large. And so we predict this is going to be an ionic compound. So we'll use the ionic compound naming rules for this guy. So the cation is called aluminum. The anion is called carbon. And that's all we need to know to write the name. So we write the cation first, as is, aluminum, space, and then we write the anion name, which is carbon, but instead of writing carbon, we add an "ide" to the ending, and so we make it carbide. All right, so far so good. But remember, when we talked about ions, we said that there were monatomic ions and there were also polyatomic ions. So what should we do if we find an ionic compound with one of those? There's a very simple adjustment, and that adjustment is if the polyatomic ion is the cation, there's no change, and if the polyatomic ion is the anion, we leave out that ending. So we don't add the "ide" ending to polyatomic anions, because we already know it's a polyatomic ion and we already know that it has a negative charge. So we don't have to indicate it in the name. So let's do an example. CaSO4. So we'll do the same process. We can see that calcium is a metal. And then we look at the second part and we recognize, because we have dutifully made flashcards of the polyatomics, we recognize this polyatomic as our cation, as our anion, our negatively charged ion, and we remember that this one is called sulfate. And the polyatomic sulfate is serving as the non-metal in this case, because both sulfur and oxygen inside of it are non-metals, and there's a large enough electronegativity difference that this is going to be an ionic bond. We are doing this process over and over ad nauseum with the same steps so that it burns into your brain how to use it. All right, so we write the cation, calcium, as is, space, and then we write the anion, and the only change is we don't add an ending, we use its name as it is, sulfate. So I would argue that naming something with a polyatomic ion is even easier, assuming you remember the name of the polyatomic. So maybe that's assuming too much. All right, let's do another example. We will do NH4Cl. So we got to go through and look and find out if there's a nonmetal and a metal. So we recognize NH4 as a polyatomic. And we remember that that one is called ammonium because it's the protonated version of ammonia. And we know that chlorine is a nonmetal. And so in this case, we don't actually have a metal, but we know that NH4 is going to be an ion. So this is obviously going to be an ionic compound because it has a polyatomic ion in it. So now we're ready to name it. We use the polyatomic ion's name for the cation. Space. And then we use the chlorine as the anion. And we're going to add that "-ide" ending because the polyatomic is in the cation and not in the anion. So those are the naming conventions for the simplest ionic compounds, monatomics and polyatomics. And we'll go over a few more rules for what to do if you end up with a transition metal in your compound in the next video.